if you came to listen to me with the hopes that you would get the lecture that was being presented on the advert, it's not what I'm giving you. I'm giving you a special case of that lecture. That lecture is about the role of philosophy in science curriculum and how science might inform philosophy in general. And what that is really is kind of an introduction into a series of explorations that I'm doing in the context of trying to engage with plants in curriculum. I've been doing some lessons and some papers related to how we might think about different philosophical questions through engaging with plants, knowing about plants, plant science, etc. And I'm going to now, in today's presentation, I'm going to go through some of my ideas about trying to link philosophical issues related to what is time, in the context of trying to understand how plants can help teach us what time might be through the different ways in which plants engage with time. As I'm doing it, one of my goals is to also be thinking about in what ways such a science curriculum or such a philosophy curriculum might engage with opportunities that occur in the outdoors, but also in what ways the outdoors might be limited for making such a marriage in pedagogy. All right. So the story started off with a plant called Chromalina odorata, which is an invasive species in Laos, where I lived for 10 years. And one of the first reasons why it struck me as being relevant to time was because it's got something that slows the thinning of blood, slows blood in it. So if you get cut, a lot of people will take it and chew it, and then they put it on your finger, which happened to me with a machete once, and instantly the bleeding stops. So it's already engaged in a very chemical way with slowing rates of change, with slowing rates of blood coagulation, or speeding up coagulation is to say, but it's a temporal phenomena. And so there's an ethnobotanical dimension to all of this as well. But that's not really what I'm going to get into today. The most interesting thing at the outset about plants, which I feel leads to them having relevance, is on the one hand, the fact that plants appear not to be engaged in temporal activities at all. They're either so slow moving, or most of their movement is invisible because it's occurring within their body. That they appear to us in our lived experience as almost just like inanimate objects. So there's a discrepancy between the particular way in which a rapid animal like a human experiences time and the way that plants engage with time. So that's an interesting contradiction that can be played with as an educator. The second reason why plants are particularly interesting is because the way in which they grow is such that their history is continuously recorded. So when you look at, say, the particular architecture of a plant, you see a visual graph of what it has gone through in its life. It's in three-dimensional space. You've got a pictorial representation of a long temporal process, and the fact that all trees of a particular species, say in this case birch, are recognizable is one thing. But the fact that this is different from every other birch tree is also relevant. Its differences relate to the particular events and decisions it's made on its unique ontological trajectory in its existence. It's very different from animals, right? Where most of our recorded history just goes inward into this invisible space. So in some way we're the inverse between what is visual and what is hidden, which leads to some interesting things. You can see that the way that a tree grows, though, there are some obvious similarities with humans in that we have long-term habits that are hard to change, which occur with us for long periods of time. Then we have things that we're learning or in the process of learning at different rates, right up until the now moment, where in the now moment, there's little details that I'm learning that come and go very amorphously. Whether or not they actually become part of me is very unlikely, right? And you see the same thing going on with the architecture of a tree, in that the most of the activity in a tree is going on in its leaves or in its root hairs. And there's a lot of possible decisions that the branch could make at that moment. But what actually gets encoded, sedimented into its being is only a fraction of its possibilities and the possible actions that it makes at that particular point. Right? So you see the same process where the now moment is represented literally in the leaves, and it gradually solidifies down into the trunk, which is the hardest thing of all to move. You need a really long and sustained interaction with a tree to shift the direction of a trunk. And that's the same thing for the most developed characters of the human. So one way in which we can think about the way that plants engage with time is through looking at the way in which the particular leaves of a particular plant change over time. So if you take, say, the buttercup, the first leaves look like this, then the next set look like this, and onwards like this. Right? If you look at all of these pictures at once, you can kind of see a movement between them, right? There's obviously, if you compare this to this, they seem very different, but you can see how there's a gradual progression, right? There's almost like a spirit which unifies these different temporal moments, which you cannot capture if you just look at a tree at a single moment in time. And in this way, again, there's a similarity with humans in that if you just look at a photograph of a human, you're not going to understand something about the way that they are. Right? You have to understand a human through time to get a sense of what their personality is and how they interact. Such an exploration is obviously something that works well outdoors because drawing plants at different stages of their growth will bring out this unifying idea that sort of interlaces it in different moments of its growth. And this is something that Goethe used to do and is relevant, is explored in Steiner and Waldorf approaches to education. So when you're exploring plants, it doesn't necessarily just involve understanding how a particular leaf changes over time, which is the particular ontogenetic trajectory of one plant. There's also ways of engaging with understanding how one plant of one species and one plant of another species are related. And this opens up another dimension of time again. So if we take two related species, for example, or two related varieties, let's say a wild rose and a domesticated rose. On the face of it, these seem like they're very different morphologically. But in fact, the difference between these is very small. And it again has to do with time. So I don't know how many of you know this, but petals are modified leaves, and stamen are modified petals, and sepals are modified stamen. So depending at what state, depending on whether or not the development of the flower of the plant has been sped up or slowed down at a certain point in time, you will lead to one of these two outcomes. So genetically, it's just all it is doing is potentially just a single gene, which is controlling a rate of change. And if the rate of change is slowed down, then instead of it transitioning from the petal form to the stamen form, it just keeps producing petals because it's slowed at that point in its development. This is like neoteny. It's the same thing that happens with humans, again. And we have the same process, in which is why we are dependent on our parents for over 10 years, which is different from most animals, and why we have hardly any hair on our bodies, and why we are open to learning is because we have a lot of infantile characteristics which stayed with us. Again, because development slowed at a certain point. Okay? So a lot of the changes that occur between species isn't necessarily going to, it has a gene for this, a gene for that. It has to do with the different ways in which evolution plays with rates of change at different moments, speeding it up at this point, slowing it down at that point. And incredible diversity of morphological forms can appear depending on these different plays of time. If we want to stretch out our conception of time again, and we can think about how evolution as a whole is represented, and there's a very misleading problem in science education in that we still tend to teach the Linnaean classification system. So Linnaeus who had developed this before evolution was even thought of as a concept, divided things neatly into all species are part of genera, genera are part of families, families are part of orders, all the way down to kingdoms and life in general. This conception leads to the idea that there's some sort of identity between the categories, like a family, like the family of legume plants, for example, is roughly compatible in some way with the family of, say, the sunflower species. That there's a set number of orders, of breakpoints, let's say, in evolution. 8 or whatever it is, major splitting events. None of these actually present the reality of how evolution occurs, where there's an arbitrary number of splittings that are occurring all of the time. This is more accurately represented in what's called cladistics, where you see that there's no set levels. There's any number of levels occurring, and in fact, if you zoom in on one of them, you get even more. Of course, from an educator's point of view, this is extremely messy. So there might be heuristic reasons for wanting to keep this. But the conception of time and of how evolution works in this organic, non-linear, sort of continuously emerging new forms sort of way is completely concealed in this conception. And arguably, I believe there's destructive reasons. The destructive event, that is not healthy for our conception of time. It certainly doesn't work with our human conception of time either, where our own life is constituted by a series of non-linear events, breakpoints that are somewhat unpredictable and that lead to new trajectories and possibilities in a way that is hardly sequential or regular. I'll skip this one because I probably don't have time. So there's a whole bunch of invisible change that occurs in plants on many different levels, and some of this can be actually quite rapid. I'll just really briefly say this, because just so you get some sort of an idea. But within a cell, you've got actin filaments and you've got microtubules, which are extremely fine threads, which are built and destroyed sometimes once a minute, sometimes every 10 seconds. It's this continuous generation process. And on those threads, especially in plants, very much less so in animals, is how it transports different organs around its cell. So it will, I'll just leave this running while you do this, while I'm doing this, but it will, move chlorophyll to certain parts of the cell, which it's deeming to be more effective in, more resource useful, for example. You've got a whole bunch of communication channels going on within the plant, You have chemical, hydraulic, electrical signals that are all happening at different rates, some inside the cell, some within the cell wall, some airborne, and some through the root system, through the soil, electrically and through volatile organic compounds. Some of these function like, there are neurotransmitters, and some of them function like neurotransmitters. There's also hormones. So there's different types of mechanisms of communication within the plant that are all operating at different rates of change, different speeds, and for different purposes, similar to how humans work. Do I get an extra 2 minutes for that distraction? I think I do.
At least 2. Especially when I start asking you questions.
I'm not sure what happened. Okay, there we go. So this is so up until so all of that stuff can be considered more like empirical conceptions of time. Now I just want to shift for the last few minutes into considering time from the point of view of phenomenologically, which means as a quality of lived experience. So studies have been done using sort of flashing techniques. How quickly can you flash a light before it appears continuous for different animals? And depending on that, you can see that different animals have different rates in which they experience time. So humans is 60 hertz, right? From our point of view, from a fly's point of view, our movements seem slower than they appear to our point of view. Much quicker. So one of the questions with plants would be, well, do they experience this kind of, do they experience any sort of lived time? And if so, is it really slow? Is it really fast? Or do they just sort of chronologically register intervals? And there's a lot of evidence to say that we're not sure. I mean, they definitely register intervals, and they register changes in intervals. So if you change the amount of light, it will make predictions on where the light will occur and how much it will occur in a certain part. But to answer this question, really, we gotta think about, well, what is the purpose of experiencing time in the first place? And because you could easily imagine a human registering time but not conscious that time exists. So this flow state of time itself is something which is entirely different from just from a chronological way of registering it. And to answer whether or not time is experienced, we have to kind of understand what time is for. And in this question, I'm taking a Deweyan perspective, and where I recognize that to think about what time is, it's important. The first step is to think about how time slows down and speeds up as we experience it, and why does it do that? In what conditions does it slow down? In what conditions does it speed up? If we can understand those conditions, then we can maybe then examine whether or not plants experience those types of conditions, and then do some sort of inference. So we know that when more changes are occurring in an environment, time slows down. We know that when stimuli is growing in intensity, time slows down. And we know that when new stimuli occurs, time slows down. Emotions also have something to do with it. Emotions that are generated through a number of neurotransmitters that plants also have. So the question is, if we want to think about this phenomenological dimension, do plants engage in environments where stimulus are changing and in intensity, in type, and does it matter? Does it matter that they have the flexibility to be able to track succession, changes in succession, to gauge the relevance of one type of change against another, and to focus on one instead of the other? And there's a lot of evidence that they do require this. And so I don't know what that's but the time is fitting. The time is fitting in this. So because that's 20 minutes. So I think it's
you can put his own theme outro music together. That's so clever.
I did not do that. Is that settee maybe? I don't know. Anyway, all right. Thank you.